So as you can see on this graph, basically we have old table, new table. We have triggers which are updating rows as the writes are hitting the old table. We have a process of copying data to the new table, and then there is rename table option. Old one is deleted, and the traffic is switched. Pretty online schema change is a point-in-time change. So that the tool executes point-in-time change. So you can use it for any DDLs. So the rename table will happen at every single slave at the same time. What is good is this tool is replication aware. So you can set some thresholds, and if the lag crosses the threshold, the tool will throttle itself down. It will basically stop until the lag go down below the threshold. Definitely this tool introduces some additional load because of the triggers which needs to be processed, and because of this additional job that runs those inserts and moves the data from old to new table. It has some limitations with when dealing with foreign keys. Basically, if the tables linked with using the foreign key is large, is big, then you may still be facing a problem with the replication lag. It can't work with tables which have triggers as of 5.6 because as of 5.6 there is no way to have multiple triggers of the same type on the table, and PT on a schema change requires to create the triggers. With 5.7 it is possible, although to be honest I'm not entirely sure how it works. It should, but I haven't tested it yet. It won't work with tables without primary keys or unique key. Because it uses those indexes to identify the boundaries for the chunks of the rows that are being copied in the background. So otherwise, other than those limitations, the PT online schema change is a very reliable tool, and even though it adds some load, even though it may take a really long time to complete, it is a very useful tool for DBA, and sometimes it's basically the only way to run a change without downtime, because otherwise you'd have to perform failovers, and it's always error prone and downtime prone. Okay, so we'll be talking now about dealing with topology changes, but first I'll go back to JJ for another pool.
Yeah, thanks, Christoph. So before we start looking at the topology changes topic, I want to ask all of you in the audience what topology you currently use yourselves, whether it's master-slave or master-master, intermediate-master, whether you operate within a single data center or multiple data centers, or it could be a combination of those two, so then there could be more than one answer to this question. But it'd be great to get your feedback here. So thank you for your participation. And while you all participate in this poll, I just want to remind you that you can ask questions about today's content at any point during this discussion by using the question section of your control panel, and we'll have hopefully a couple of minutes towards the end of the webinar to answer them. And if not, we'll answer your questions as a follow-up directly via email as well. But thank you for participating in this poll for now. I'm going to close the results. I'm going to close the poll and share the results. Here we go. So the majority of you seem to be using master-slave, and then there's a master-master group of people. Christoph, any comments on this?
Yeah, I mean, this is a very nice example of the fact that MySQL application is really flexible, and you can deploy it in a very different type of way. So I'm not really surprised by those results.
Great. Well, thanks everyone for participating in this poll, and I'll hand back over to you, Christoph.
Okay, thank you, JJ. So yes, as I said, we'll be talking now about topology changes within MySQL replication. So the thing is that if you're using global transaction ID, if you're using running 5.6 or later, and you're using GTID, topology changes are easy. Basically, GTID allows for a very flexible topology change. What you need to run is change master2, master host, master user, master port, master password, master auto position equal to 1, and that's it. And slave, you can slave off any point and this node in your replication topology at any place. What you want to keep in mind, though, are the errand transactions. And this is something which we'll be talking a little bit until towards the end of this webinar. If you're not using GTID, things are a little bit complex. Problem here is that the slave knows the binary log position of itself. For every event, it knows the binary log position of itself and the master. And therefore, it is kind of hard to make changes in real time, and it's also hard to make changes that would point slave to some completely different place in the topology. There are ways to do that, but there are that's a complex process, and possible it could be also error-prone process. So so ideally, to avoid some issues, if you want to move slave around, you most likely need to stop the replication at some subset of the slaves. And I'm not going to talk in detail about this whole process. I just want to show you more or less how it looked like. We actually covered this process in one of the webinars in the last year in more detail. So, but it's just so you can see how it looked like, and that is slightly more complex than just running change master2, and that's it. So let's say that we want to, promote the DB2 as a master in a replication, regular replication. So first of all, we have to stop DB2, DB3, and DB4 at the same position, because we want DB3 and 4 slaving off DB2. And for that, we need to stop the replication on basically, as you can see, on basically all slaves, inducting lag, of course. So we run start slave until we, and then we need to run flash logs, and then we need to check the position, and then of the DB2 and 3 and 4, make sure that they're on the same position, and then find the position of DB2, and then slave DB3 and 4 of DB2. And this is already a process in which you could make at least 2 or 3 mistakes, resulting in, in one of the slaves that this basically needs to be rebuilt. And I've been there and I've done that, unfortunately, a couple of times. And then the rest of the slaving of the preparation process will require setting up DB1 and DB2 master replication. So again, we have to confirm that there are no writes hitting DB2, and then we want to we need to set up the replication. So we need to check the binary log, the server ID is correct, and all this stuff is required to finally promote DB2 as a new master. GTID does not fix all of those problems, but it fixes at least a good half of them. Therefore, it is really much easier and much less error prone with using GTID, and that's really why it is very, it's very welcomed by the DBAs. Makes their work much easier.